Assalamualaikum. Hi everyone. It's me again, Mina Azida, to continue the next subtopic for chemical bonding, which is orbital overlap and hybridization. The part A, draw and describe the formation of sigma bond and pi bond from overlapping of orbital. For B and C will be discussed in your tutorial class. Overview for topic 4.3. We have three parts, which is first is draw and describe the formation of sigma and pi bond from overlapping orbital. Draw and explain the formation of hybrid orbital for central atom. So we have 5 hybrid orbital: sp, sp2, sp3, sp3d, and sp3d2. And last one is draw orbital overlap and label sigma and pi bond of a molecules. First, before we go further, we need to know what is actually valence bond theory. Valence bond theory is theoretical model that explains covalent bond. An important concept in valence bond theory is covalent bond formed by sharing electron from overlapping of atomic orbitals. The space formed by overlapping orbital has a maximum capacity of 2 electrons that must have opposite spin. Due to the overlapping, electrons are localized in the bond region. The strength of the bond depends on the degree of overlapping. As the number of orbital overlap increases, the bond strength also increases. Covalent bonds are formed by sharing electrons from overlapping atomic orbitals. For example, we have 1s and 2p. And overlapping here is show opposite spin. Direct orbital overlap. Atoms in simple molecule or ions such as hydrogen gas, hydrogen fluoride, nitrogen gas normally use pure s orbital and or pure p orbital in forming covalent bonds. For example, orbital s will overlap with s orbital. Orbital p will overlap with p orbital. Orbital s will overlap with p orbitals. So, for example, if s orbital overlap with s orbital, such as hydrogen gas, electronic configuration 1s1. So, in orbital 1s only contain one hydrogen, and the other hydrogen, the one is also represent 1s1 and contain one electron at orbital 1s. Next one is to show the formation of molecule hydrogen. Both electrons must be overlap each other. One s from one H and the other H represent also one s orbital and end up given H2 with opposite spin. S orbital overlap with p orbital. For example, hydrogen fluoride with different electronegativity. So, hydrogen electronic configuration is 1s1 and in orbital diagram consists only one orbital, one electron. And for fluorine is 1s2, 2s2, 2p5. And the valence electron for F fluorine atom is 7. So that means fluorine atom need only one more electron to become octet. So hydrogen electron at hydrogen will occupy the electron in the fluorine atom, and then s orbital overlap with p orbital. One is come from fluorine atom and one is come from hydrogen atom, and fluorine atom represent dumbbell and hydrogen atom represent spherical. What about p orbital overlap with p orbital? For example, a fluorine molecule. Fluorine molecule consists of two fluorine atoms. Each fluorine atom has valence electron 7. To form a fluorine molecule, one electron from one fluorine will overlap with one electron in the other fluorine atom, and the overlap consists p orbital with also p orbital, and the shape is dumbbell. Opposite spin, and that produce a sigma bond. Mode of overlap. If end-to-end overlap, we call it as a sigma bond. If side-to-side is pi bond. End-to-end is sigma bond. Side-to-side overlap is a pi bond, and the side-to-side overlap must be parallel each other. Resulting from end-to-end overlap produce sigma bond. Sigma bond has highest electron density along the bond axis. Sigma bond also allow 3 rotation. All single bond are sigma. Example of overlapping between original orbital. Let's say we have s orbital, 2s orbital, and shows end-to-end overlap represent sigma bond. If one orbital s overlap end-to-end with dumbbell, which is p orbital, end-to-end here overlapping, we show the sigma bond. If overlapping between two dumbbell with opposite spin, we show sigma bond. Overlapping with hybrid orbital. Let's say we have sp hybridized will overlap with pure 3p, and also end-to-end overlap will produce sigma bond. What about if we have one orbital s and overlap with sp hybridization also will produce sigma bond. Pi bond. Pi bond is side-to-side overlap. Has two regions of electron density, one above and one below the sigma bond axis. Example, we have one dumbbell and 2pz orbital will overlap with also 2pz orbital, and here it shows side-to-side overlap will produce pi bond. If one pi bond holds two electrons that move through both regions of the bond and pi bond restricted rotation, double bond consists one sigma bond and one pi bond. For example, this is sigma bond and this is pi bond. Oxygen gas has one pi bond and one sigma bond. Oxygen atom has 6 valence electrons. So based on the electron in orbital diagram, two orbital of 2p orbital consists only single electron. And when one another of oxygen atom is share electron with 2p electron, and then next is with share electron will produce pi bond. This is overlap, parallel, side to side. We produce pi bond. And here is end to end that produce sigma bond. Triple bond consists one sigma bond and two pi bond. For example, we have cyanide ion. Cyanide ion has two pi bond and one sigma bond. Example 1. Adrenaline has the following Lewis structure. How many pi bond and sigma bond are in the molecules? This is sigma. This is sigma. 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 This 6 sigma bond. For pi bond, okay, this is pi. This is pi. This is pi. We have 3 pi bond. The triple bond contains how many sigma bonds and how many pi bonds? Question number 2. A pi bond is the result of, and last one is a single pi bond can be drawn as a... Okay, that's all for today. Bye bye.